Another new feature in Server 2016 and the next level of virtualization is containers. Hyper-V gave us hardware virtualization, containers give us operating system virtualization. So in this nugget, we're going to take an introduction to containers. We'll talk more about what they are, the benefits they provide, the technology that makes it all work, and the kinds of containers that we can create here on Windows. From there, we'll jump into the virtual lab and spin up a couple of container hosts. We'll also get Docker, the underlying open source technology that makes it all work, installed and configured. Let's get started. To really understand why containers are important, why they've become so popular, and why they're the next level of virtualization, it helps to take a look at the big picture. Now, in the old days, prior to any form of virtualization, if we needed to support an application, we would usually dedicate a physical machine to that application. So we'd buy the expensive hardware, install the operating system and the application, and any dependencies that application required onto that physical server. And of course, we usually had a lot of applications we needed to support, which would equate to a lot of physical servers. Not to mention the infrastructure services like DNS, DHCP, and Active Directory, and the end result here would be a data center full of expensive physical servers with a lot of wasted resources. Fast forward a little bit, and hardware virtualization hits the scene and becomes very popular. We call this phase one of virtualization because it allowed us to buy just a few big physical servers and use virtualization software like Hyper-V. Then we can consolidate a lot of these apps and infrastructure services onto virtual machines and pack them tightly onto our Hyper-V hosts. And this worked out great for a long time because of those hardware cost savings, better resource utilization, and VMs were a lot easier to work with and much more portable than physical machines. But over time, new challenges started to arise. Virtual machines, while portable, were huge because of the operating system that we still need to install on each individual OS, not to mention licensing costs that go with that. So this is where phase two of virtualization, containers, came about to solve the challenges we have with dedicating an entire VM to an application. So how this works is we would spin up a container host. That host would have its own operating system, and then we would use tools like Docker to download a base operating system image. Then we can create containers, which are isolated environments for our applications and services that reuse the base operating system. This model brings with it an insane amount of benefits, which is one of the primary reasons that Docker and containers have become so popular over the past few years. Number one, containers are incredibly fast. They load up nearly instantaneously because they don't need to load an operating system. That base operating system is already loaded on the container host. Number two, we still get isolation because whenever we fire up a container, that OS is going to project a copy of itself into that container fully loaded. So each container will have its own OS, its own file system, set of processes and services. And when you're in a container working, you feel like you're just in its own little VM without all the downsides of a big, thick, heavy VM. Containers are also highly portable and reusable. And a lot of this is due to the fact that containers are image-based. In fact, Docker and Microsoft provide us with a repository for storing these images. Microsoft has a repository for their base operating system images. We can create our own images on top of these, which contain our applications and their dependencies. Now we can spin up other container hosts, and these can be physical machines, virtual machines, cloud-based machines. Once we install Docker and download these images, and we could just download maybe our application image, which sits on top of our OS image. That machine will download the base OS image, download the application layer on top of it, and then we can spin up containers based on that application. Here's the real beautiful thing. Developers, they're going to be working inside of these containers on their application. When they're done, they're going to take that image and upload it to the repository. So whenever our container hosts need to download the latest version, they don't need to re-download all the bits they already have. They just download the changes. So it's really an incredible technology that everybody can and should be benefiting from today. Now in Server 2016, Microsoft has not only provided us with containers, but added their own little spin to it because there's two kinds of containers. We have Windows containers and Hyper-V containers, and really the big difference between these is the level of isolation that they provide. Windows containers have isolation at the container level, but have a shared kernel. And so this is something that you should be using entirely in trusted environments, right? IT shops supporting their own applications. So if a single container compromises that shared kernel, well, you have a potential security situation on your hands. Hyper-V containers, on the other hand, which by the way does require Hyper-V installed on your container host, provides us with isolation at the kernel level. So there's no possible way that a container could compromise any other kernel on the system. And this is something that you should run when supporting multi-tenant environments. So that's containers in a nutshell. Let's jump into the virtual lab and spin up a couple of container hosts. We'll get Docker installed and configured. We'll get familiar with all the components that make it work and get everything ready in the virtual lab for our future container nuggets. We have a 4-machine lab to work with here throughout our containers section. We're going to be spending a good majority of our time here on AdminNug. This is our Windows 10 remote administration machine. We'll be using PowerShell to remotely manage both CN1NUG and CN2NUG. Both of these we're going to transform into container hosts in this nugget. CN1NUG is Server 2016 with the full desktop experience, and we'll be using Windows containers there. CN2NUG is our nano server. We'll be installing Hyper-V on this and running Hyper-V containers on there. Now, you do not need Hyper-V to run containers, you just need it to run Hyper-V containers. But you can certainly put both of these on a single container host and still run both Windows and Hyper-V containers. In fact, it's just a switch when we fire up our containers what our isolation mode will be, Windows or Hyper-V. So let's go ahead and begin here on AdminNug. I'm going to paste the password in and log in. Let's start on AdminNug by launching right into File Explorer. From here, let's go into the Nugget Lab directory in the root of the C drive, and let's launch our commands.ps1 script into the ISE. Let's start with our CN1NUG machine, which is server with the desktop experience, and let's PowerShell remote onto that machine. So we'll run an enter PS session against CN1NUG. All right, that looks good. We're on it. Now, our first order of business is to install the Docker Microsoft provider. So we can run an install module targeting the PS Gallery repository, and this will get us everything we need to install Docker and the containers feature here on CN1NUG. So let's run this one first, and it's going to prompt us here for the to download the NuGet repository. So go ahead and choose yes at the prompt, and that'll just take a second to complete. Now we can install the Docker package from that repository. This is going to install the Docker client and the Docker daemon and turn the daemon into a Windows service. So let's go ahead and execute this line of code. This is also going to install the containers feature here on this machine. And there it is. At a restart of this machine will be required to start the Docker service. Now, just to prove here that that did in fact install the containers feature, let's open up Server Manager. And I have both of our machines here, all of our machines added into Server Manager here on our Windows 10 remote administration machine. If we choose all servers over here on the left and choose CN1NUG, notice it says restart pending there, and choose add roles and features against that machine, that'll target CN1NUG directly. Now we can hit next a few times until we get to features, and we should see containers is now installed. Cool, so that'll give us support on this machine for containers. Now, you could do this through the GUI, install that feature separately, and then you can also download the Docker client separately outside of it. But it's really nice that in 2 PowerShell commands, we can do all of that. This will always provide us with the latest stable release inside of the provider. You can also download the latest Docker betas. That you will need to do manually. So this looks good here on CN1NUG. Let's go ahead and restart that machine. And while that's restarting here, I'll exit out of our PowerShell session as well. So I gave CN1NUG just a second to reboot. It should be good. So now we can PowerShell remote back onto that machine and take a look at what that did. The first thing it did, as we scroll down a little bit here, is install Docker in 2 places. The first one is the installation directory for the binaries themselves. So this will be stored in program files, Docker. If we run a get child item, we can see that docker.exe, that's the client, dockerd is the daemon. And if we take a look at the actual root directory where it stores everything else, config files, images, all that stuff, it's in program data/Docker. So if we take a look at this, we can see everything inside of here. And if we look at the service here, we can run a get service against Docker. It should be in a running state, and it is. So installation was successful. Everything looks good. We can also run the Docker client here to take a look at the version of both our client and our server. So this is the client here, and this is the daemon itself. We can also run a Docker info to take a look at our current configuration. And if I scroll up to the top here, this will give us a nice overview of the stats, current containers that are running, pause or stop, the number of images that we have, and also we can take a look at our root directory's installation path. We're actually going to change this, and it's right here, Docker root, program data Docker. So I'm going to show you how we can use a configuration file, which is just a file full of JSON to configure Docker. And this is for configuring the daemon, the server side itself. And before we do that, let me show you a little something here. Let's open up Internet Explorer, hit the favorites button up here on the upper right, expand the favorites bar, and I included a link in here for Dockerd's configuration for the daemon itself. Now, open source Docker supports a lot of configuration. Windows supports a subset of that. This is why in their documentation they show us what those options are. You can see them in here. There's still quite a few of them, but how this works is you only need to create the JSON and the key value pairs for whichever configurations you want to include. You don't need to enter all of these. And just to give you an idea of some of the popular ones here, we have bridge. This is how containers are going to network with other containers and the host itself. By default, it's set up for NAT. And think of it just like our container's a little VM. It's got a virtual network interface card attached to it, and it's connected to this to the switch, which has NAT enabled on it. We'll look more at networking features in a future nugget, but this is where we would control that. We can set up DNS here. Graph is how we can change the default installation directory for the root of the Docker daemon, which is what we're going to do here shortly. We can do things like include what groups have access. By default, anybody in the local administrators group. We can control what IP and port the Docker daemon is listening on through the host value here. And there's a lot of other ones. All right, so all we need to do is create this JSON file and store it in the config directory, which is located right here in program data docker config. So what we're going to do is we're going to create a little bit of JSON here to configure that graph property, which will change this default root dir to c:\wac Docker. And you do need to escape your backslashes here. That's why we have two of them inside of here. So we're going to store that JSON into a variable, and then we're going to pass over to set content, which will create the daemon.json file there in that config directory. There we go. Now all we need to do is create the local path where the new directory is going to be. So we'll run a new item here. So that'll create c:\wac Docker. And now whenever you make any configuration changes, you'll need to restart the service to pick it up. And you'll know if you have a misconfigured setting in here, maybe you spelled something wrong or entered something wrong, you have bad syntax or format or whatever, the service will not start. So this is how you can see if your configuration changes were successful, the service will restart successfully, as it did. We didn't get any error messages back. And then you can rerun a docker.info to see what some of those configurations are. A lot of the most popular ones are in here. And if we look at our Docker root directory, we are now good, pointed at the Docker directory that we created in the root of the C drive. And we can verify that by heading over through the administrative share there on cn1nug, $, and there is our Docker directory, and there is everything inside of it. Cool. So our first container host, cn1nug, is done and ready to go. From here, you would download your base images and then fire up a container based on that image, install your own stuff into it, and then create your own image on top of that. That's where we'll pick up with our next nugget. Before we get there, let's spin up our second container host, which is going to be our Nano server. And this is going to look very similar. The big difference, though, is that we're also going to install the compute package, Hyper-V. That way we can run Hyper-V containers over here on CN2nug. So I'm going to go ahead and exit out of our session here on CN1nug, and let's get a session going on our Nano server, CN2nug. So again, the first thing we need to do here is install the Docker Microsoft provider and then install Docker through that provider. Same exact PowerShell commands here, so we're going to execute those both at the same time. All right, and that's done. And you can safely ignore this first warning here. I did perform a Windows update on our Nano server, and we should always keep our machines up to date anyway. But with that done, before we reboot here, let's go ahead and also install Hyper-V onto our Nano server. So we'll run an install Nano server package here, targeting the compute package. That completed successfully. Before we go any further, we should reboot our machine. So let's go ahead and reboot CN2nug. And while that's going on here, I'll exit out of our session as well. All right, CN2's reboot is complete. Now we can get back onto a PowerShell session once again over on our Nano server. And let's do the same thing here. If we scroll down a little bit, we can take a look at both our install directory and our root directory for the daemon. And there they are. So there's the first three from our program files Docker directory, and here is our root directory for the daemon containing all of those directories. Now, one thing we'll need to do on a Nano server is set the startup type for the Docker service to automatic. So let's go ahead and do that. Cool, and now we can restart the service. We could just run a restart service as well, but it's currently in an off state. In fact, if we run a get service here, targeting Docker, we should see that it's currently stopped. So a Nano server doesn't start up automatically. That's why we set that startup type. And now let's go ahead and just start the service, and now we're good. All right, we can run a Docker version and a Docker info here. Let's start with version. We can see we're on the same version here on our Nano server for both the client and the daemon. If we run a Docker info, we can also see its configuration and current stats. And we'll do the same thing here. We will set up the default root directory here to point at the local Docker directory. So let's do just that here. Let's go ahead and first create our configuration. There it is. And now let's create that Docker directory in the root of C. Perfect. Now we can restart the service and it'll pick up those changes, and we can verify that here if we run a docker info. Once again, there is our brand new root directory. And that's it. We have both of our container hosts ready to go. We have the container feature installed, Docker installed, and we'll use this as the starting point for our next couple of nuggets where we'll learn how to create, configure, and manage containers. In this CBC nugget, we took an introduction to containers on Server 2016. We saw that containers are the next level of virtualization. We talked about the benefits they bring, the components that are involved, the two types of containers that we can create in Windows, and we even got into the virtual lab and stood up 2 container hosts by installing the container feature and Docker. I hope this has been informative for you, and I'd like to thank you for viewing.